Hey everyone, thank you so much for coming, and thank you to the organizers for having me. So over the past few years, I've spent thousands of hours studying how various companies have scaled their security. And not just the one-off ad hoc wins, but the things that have truly systematically, scalably raised their security bar. So my goal in this talk is to collect a bunch of tactics and strategies and create a playbook from which you can take different parts and then apply them for yourself and your company, whichever parts make the most sense. So I'm going to be distilling and aggregating a vast amount of information. So over 50 different conference talks, dozens of tools, blog posts, and in-person conversations I've had with security engineers at many, many different companies. So these are just the logos of some of the companies that I'm going to reference their work in this talk, but there's more. I also just wanted to say, you don't have to write down every slide or take pictures of it. On the last slide, there's going to be a link so that you can see these Google slides right then. And also, this talk is recorded, so don't stress out about it. You won't be able to read everything. So a little bit about me before we get started. So I'm a technical director and research director at NCC Group. We do security consulting, so pen testing for web apps, networks, and so forth. We've also been helping companies with their DevSecOps transformation, security automation, and things like that. So some of this material is pulling from that as well. Here are some of the things I really enjoy. So if you also like those, come up and say hi after. I'd love to learn from you and chat about it. OK, so there's some things that I'm just going to sort of assume and not get into a lot of detail. I think many people have found that traditional SAST and DAST are overall not as useful given the operational time required from the security team as well as the cost. I assume you're willing to invest a lot of time now, or some time at least, in order to reap big security wins later. And I assume your security team has a few people, but not necessarily dozens or hundreds, right? So you're somewhere in the middle. You're not just starting, but you're not maybe, say, Google or Facebook. So again, this is not a starting a security program talk, but if that's your jam, here's some places to start. OK, so this talk has three main parts. So first, we're going to talk about some sort of big picture security mindset type things, how to think about security effectively. And then the bulk of this talk is the middle section, where we're going to talk about some specific strategies and tactics you can use to scale your security. So first, some fundamentals that are nice to have. Then how do you scale that? And then finally, what might this look like, say, a couple of years in the future? And then finally, we're going to tie it all together. Cool. So first, some mindsets and principles. So first, I think everyone would agree with this first one. Security teams are always time and purse limited, so fundamentally you need to automate to scale. And one trend I see at many companies is that you have to minimize your no's, right? You have to build these nice secure guardrails that allow developers to do their job securely as well as just faster and better. I think Asta and the Netflix team talks about this very nicely in their concept of a paved road. Many companies are choosing to prefer high signal, low noise tools and alerting. So it's OK if we don't find everything, but when the tools do say something, we want it to be actionable and a true positive. And I think that's an interesting change in perspective I've seen at a number of companies. So when we're building products, oftentimes we spend a lot of time thinking about how do we make a nice UI and user experience for users. But as security team members, I think that we should think of developers as our customers. So how can we fit into their existing tools and workflow? Can we make the secure way easier, faster, or just otherwise better than how they're doing it already? Right? We're introducing friction into their world when we're asking them to change how they're already doing things. And lastly, this concept of self-service security. So can we provide tools and services that developers can use without even talking to the security team? So I wrote about some of these in a bit more detail in a blog post you can check out. And I wanted to make sure that I could connect with the youth in the audience. So I included this. So to sort of thematically summarize this talk, broke is finding individual bugs, and woke is scalably reducing risk. You heard it here, folks. OK, so in life as well as in security, you're always choosing whether to focus on the now, the medium term, or the long term. And in this talk, I'm going to push you very strongly to always be forward thinking about this long term. Specifically, ask yourself, of my near and medium term tasks, which of these is going to provide the most long term strategic value? Can I do a near term task a little bit differently to make it more useful later? And then also, what subproblems can I solve precisely, that is high signal, as well as at scale? So maybe there's 50 things you want to find, but some of them you can do very precisely such that you just handle them, and then you don't have to deal with it anymore. And we're going to talk about that a lot soon. Another thing I like to think about is when you're approaching security, there's many different tools you have in your tool belt, right? So you have static and dynamic analysis. You have bug bounty and pen testing. You have secure wrapper libraries as well as threat modeling. You have runtime detection. You have fuzzing, of course, that's the SAW. And I think the point I want to make here is that depending on what you're trying to do, there are certain approaches that are just fundamentally better or worse. So rather than saying, oh, how do I make tool X better? Instead ask yourself, is tool X the right even approach for this problem I'm trying to solve? And another thing that I think is very important is choosing what to ignore, right? So there are some fires that you just have to let burn, at least for a time. So Adam said this on LinkedIn recently that I liked. So the question isn't, is this thing useful? But given finite time and resources, should we be doing this versus something else? Because ultimately, security and life is trade-offs. Okay, so another way I like to look at things is targeting vulnerabilities by either the complexity of the analysis required to find them, as well as what vulnerability class they are. So let's look at some examples. So something that doesn't take a lot of context, like a lot of algorithmic complexity to find, is does this, say, web app have TLS on it? You know, is it using the right security headers? Calling dangerous functions is essentially just greps, but you can have some nice security wins there. And then things that take a little more complexity of analysis, like standard OWASP bugs, cross-site scripting, SQL injection, and so forth. And then on the hard side, we have these complex multi-step bugs, business logic flaws, abusing built-in functionality, and so forth. So when you're first starting a security program, you might say, OK, let me just buy a bunch of tools, and this is going to handle all of our problems, and we'll be blissfully happy. Or you might say, oh, let's just pen test all of our problems away. But I think as your program develops and becomes a bit more mature, you're going to want to make it look a little bit more like this, where you've built some nice secure defaults, which are handling many of the easy cases, and a lot of the medium cases, and even some of the hard cases. You have automated tools that are, again, catching some low-hanging fruit, but sort of less medium and high complexity issues. Bug bounty definitely plays a very useful role in getting some continuous coverage. And then I think the true value of pen tests here is finding these sort of medium and hard complexity bugs, the things that require a lot of context and tools may not find. And runtime monitoring is useful for finding some things you just can't really find easily other ways. So just quickly, solve as many of your problems with secure defaults. Tools are not going to solve all your problems. Bug bounty does give you some nice, decent coverage. If all of your pen tests are just finding these sort of easy type vulnerabilities, you're not getting the most value from it. And runtime monitoring for bugs is useful for certain classes that you just can't easily find other ways. OK, so that was my opinion. Let's look at how some other people think about it. So this is from Patrick and Asta's AppSec Cali talk 2 years ago. So notice how on the left-hand side we see manual testing, per app threat modeling, traditional vuln scanning is de-emphasized. And then on the right-hand side, building a paved road, so secure defaults, self-service, and killing bug classes is emphasized. They gave an updated version on a different topic, but also Netflix, Scott and Isha. And notice how the heavy emphasis on secure defaults, and then notice how that is growing over time. So I think that's very interesting. OK, so now let's get into the meat of it. So these are sort of core tactics and strategies. So I'm going to start with fundamentals. And these are fundamentals not because they're easy, but because if you have a strong foundation in these, you can build very high leverage, scalable things on top. OK, so vulnerability management. You need to know where you are now, and you need to know if what you're doing actually works, right? Something might sound great, and you may invest a quarter or 2 quarters working on it, and it may not actually move the security needle. So this is very important. So some success criteria for this. You want to minimize friction for developers as well as security. You want to track vulnerabilities, ideally in the same system, such as Jira, that bugs are tracked in, so developers don't have to go multiple places. Regardless of how you find the bug, whether it's bug bounty and so forth, just triage it through the same process. And it's nice to track relevant metadata. So what are some examples? What code base was affected, the team and org involved, what vulnerability class. And OWASP, I think, is a little bit too coarse for this. I would encourage you to use a slightly more detailed taxonomy, maybe of like 20 to 40 type things. This will let you do some cool stats that we'll show in a second. Also, how severe was it? How much do we care? And also, how was it found? As you're scaling, you might care a little bit about what was the root cause, what code introduced it, were there mitigating factors, and so forth. Okay, so as you're sort of leveling up and scaling this, if there's parts you can automate, that's great. Many organizations have found some success building a vulnerability or risk dashboard that you can sort of slice and dice by team, code base, et cetera. So this gives you a nice high-level intuition as to where should I invest my security engineering efforts. And a couple of companies have found that it puts friendly pressure on teams to improve. No one wants to be the team where all their stuff is in red. So here's some good talks about this. And the second one, Arcadie's talk, I like a lot. And we're going to see a couple of figures from it. So the first is this one. So this is open security vulnerabilities by priority last 90 days. So if you are overall getting better, if your mitigations and protections are working, this should ideally trend down over time. Similarly here, when you have open vulnerabilities by sub-team and priority, it very quickly becomes clear, oh, we should reach out to this team and give them some help. Maybe there's some systemic issue they're having problems addressing. This idea was given to me by Emre of Salesforce. So again, if you're tracking, these bugs were from Bug Bounty, also what vulnerability class they were and how much we paid. So you could actually say things like, this vulnerability class objectively costed us this much money. And this can help perhaps get additional buy-in from upper management in terms of investing time and resources. Okay, here's some example dashboards. So this is from a Domino's AppSec USA talk. So you can see like, oh, which of these sort of microservices might we want to invest more resources in? And you don't necessarily need to know the technical details of, oh, this is what cross-site scripting is. Like execs can look at this and have an intuition about what they might care about. This is from a Netflix talk again. So there's a couple of columns where basically has this microservice used one of the security controls we built for it? Yes or no? Is it a high-risk service? And then you can sort of slice and dice on the right-hand side with various filters. Okay, let's talk about continuous scanning. So the idea is we want to be able to scan new code with static and dynamic analysis tools. Usually static is on developers' machines and code hosting, and then there's a bunch of things you can do in testing QA. So due to time, I'm not going to talk about any of those. However, in the backup slides, of which there are about as many as main slides, I will talk about all of these in more detail. So one of the interesting things I found is this idea of like a continuous code scanning pipeline is one of the most popular ideas in DevSecOps. Many companies have talked about how they do it. So here is a number just only at AppSec USA. Here's a bunch more at other conferences, right? So this is all companies talking about how they sort of continuously scan code. So the details vary by company, but let's talk about some things they all generally agree on. So first, it's very nice to be able for the security team to iterate quickly. So adding and removing tools into the pipeline, testing new rules. Generally, people choose to scan pull requests. If you scan every commit, maybe there's a work in progress commit you don't care about and it's too noisy. Ideally, scan should be very fast. You're giving developers feedback while the context is fresh. If you're doing more in-depth things, maybe that can be done daily or weekly. Generally, if you can show tool results within developer systems, for example, a comment on the PR so they don't have to go somewhere else. Ideally, checks are very high signal. If you're going to auto send it to a developer without triaging it, you don't want to annoy them. Because if it's very low signal and they spend a lot of their time triaging, this generally makes them dislike you, and it's a lot of overhead time for your team. Obviously, you're going to want to capture metrics. So what are we finding? What's our false positive rate? Things like that. You'll probably need to build some deduplication and whitelisting logic. And then finally, being able to map reduce over all of your code and live systems is pretty neat, and we'll show why in a second. Okay, so also just how to think about this. Here's a couple of other good talks. And one thing I just want to dive into a little bit more detail, when people think of static analysis, a lot of times they think about one of these two things, which are sort of on opposite ends of the spectrum. So one is you're doing something very like sort of easy from a analysis complexity point of view, right? Regex is operating on strings, very easy to run and write. Or you have very complex heavyweight analysis with sort of SAST where you're doing control and data flow. So the trade-offs here, you can be very fast and not very expressive, or you can be very expressive, but maybe a bit slow and noisy. But there's actually a middle ground doing sort of security linting or abstract syntax tree matching, which I think is very interesting. So here you are source code aware, so you can say like match this conditional or match this function call. So you can do some of the complexity of SAST, but you're still fast, but you can't do quite everything SAST can do. So I think this is a very interesting space that I'm optimistic about. A couple of people have given talks about this. So Justin Collins, the creator of Brakeman, gave the first talk. Myself and a colleague gave the second one. And Instagram had a pretty nice detailed blog post about how they do AST matching on their Django monolith. Okay, so if you are going to do this yourself, generally what you're going to do is go from source code, you're going to parse it into an abstract syntax tree. There's a couple of ways you can parse, either with a language-specific parser, a parser generator like Antler, or in my opinion, the best approach, which is a parser that handles multiple languages. So if in your environment you have a bunch of different languages, you probably don't want to find a separate parser for all of them. So let's look at a specific example of this to make this more concrete. Let's say you have a bunch of Node.js code and you want to find calls to exec where the first argument is not a string, right? So like any trusty security professional, you decided to write a regex for it. And it might look like this. But then you might find code like this, where it's on multiple lines, or the end of the function is exec, but it's not the one you meant, or maybe it's in a comment, maybe it's in a hard-coded string. And quickly you become a little bit sad. Like what you want to be able to do is say, find me all function calls such that the function call is this name, right? Conceptually, this is very simple. So there's actually a tool that's free. It's on GitHub right now called sgrep or semantic grep. And you can think of it like a code-aware grep. So in this example, you could say sgrep-e exec ... And you're just saying, find me a function call whose name is exec. I don't care about the arguments. It can also use this idea of meta variables where you might say, find me all conditionals where the if and the else body are the same. Right? Generally, that shouldn't happen. It's a little bit weird. Or you could say, find me calls to bodo3.client where there's this dict argument where the values to the secret access key and key ID are hard-coded strings, right? So you have hard-coded secrets. So again, the idea is, I have an idea in my head. How do we express this as cleanly as possible? Okay, so we talked a lot about how, so what to look for. One thing is high signal vulnerability checks and security anti-patterns. For example, disabling TLS. So if you see this, probably it's bad. You might want to block banned or dangerous functions, for example, calls to exec or eval. Mozilla has some ESLint plugins to do that. Maybe it's not a bug, but it's just some security additions to the code that's interesting. Like, hey, I see you're doing crypto stuff. Like maybe we want to reach out to this development team. You can also alert on sensitive file changes, like the authentication or authorization flow, the login flow, things that probably shouldn't change that much, and the security team wants to know about it. Here's a couple of tools that generally are not too shabby. Okay, so there's a nice talk by Aladdin of the Netflix security team about how they deal with open source vulnerabilities at scale. Every language has their own tool. There's a bunch of commercial tools. You can look it up. Another thing that's interesting with this move to DevOps and Terraform and so forth, there's a number of security linting tools for those infrastructure as code things. So here's a couple of examples. So key takeaways from this. You want to have the capability to scan every pull request, code base, and deployed service. Ideally, you're using high signal checks only. And we're not necessarily finding every bug. We're just ensuring a security baseline. I think that's like a key perspective shift that's useful. Right? So you might be scanning for missing security controls and security relevant changes. Okay, last fundamental. So what is it? It depends on who you ask. But for me, it's a list of the things you own. So code, servers, databases, and so forth. So maybe this is a black box external point of view where you're using OAuth and certificate transparency. Maybe you give the tool access to your AWS environment, and then it sort of programmatically figures out what you own. Or this last one, white box, holistic. So maybe you give it a key to GitHub as well as other tools you use, and it sort of uses their APIs to figure out what does your environment look like. So the core idea is we want to know what we own and how they connect. So first thing that's useful is code and cloud. And there's many things, but I would start here. So knowing in each repo what's the owning team, who's the security point of contact, and so forth. And then in the cloud environment, what services are we using, what do credentials and roles and network ACLs look like, and so forth. And as you go along, it's nice to build capabilities to get visibility into other assets. Being able to, for example, track code from when it's in the repo to QA and staging all the way to production is nice. And so we're getting visibility into all these different parts of our ecosystem, and being able to query across things is very nice as well. So Sasha from Lyft talked about this at BSides last year and released a tool called Cartography. It's pretty neat. And then Erkang, they're working on like a commercial version of it, basically. And then there was a talk by Rob and Oscar where they also give some nice overview of the asset inventory space. Okay, so the idea of cartography is basically let's enumerate all of our assets, what we own, and then represent them in a Neo4j database where each node is like an entity and edges are relationships between those. So here's some things you can do. You could say which RDS instances have encryption turned off, which EC2 instances are directly exposed to the internet. And let's look at a little bit more advanced, but I think more realistic and interesting example. So let's say your company happens to run something like struts. And you might know where I'm going with this. Let's say there's a new critical RCE. It has a cool page, a cool logo, and maybe you're a bit unhappy about it. And let's say there's also a curl POC that's been released in terms of like how to diagnose if you're affected. So if you have a nice asset inventory and some of these fundamentals, what can you do? So first you could say, okay, figure out what are all the servers I own and where are they. You could then, again, using this sort of MapReduce type functionality, run curl on all of those to figure out which of these are actually affected. And again, you can say, oh, I know which services are running where, so I can actually say, oh, these vulnerable ones, I actually know which repo is responsible for those running services. From there, you can say, oh, I know the owner for those repos. And then you could say, oh, let's send an automated email or Slack message or create a Jira ticket assigned to those people who are responsible for the repo that is responsible for the struts vulnerability. Right? So we're taking a incident response scenario that might take hours or days to respond to and cutting that down to ideally only a couple of minutes. So this is for incident response, but it could be applied in many ways. Okay, so let's talk about scaling our efforts. We'll talk about a couple of areas. So many companies find they can't threat model every story, so what do you focus on? There's been a bunch of work in this space, but I think it boils down to three main areas. So one is having developers fill out self-service security questionnaires. Basically, here's what I'm thinking about doing. Here's the sensitive data it touches. Here's sort of the risk of the types of things I'm doing in terms of like parsing XML, maybe parsing URLs and so forth. And then basically it spits out, here's some things you should make sure to do and a risk score so the security team can prioritize. Or you could have some lightweight threat modeling in the SDLC itself. Maybe after they talk about what features are required for acceptance criteria, you could say, oh, also how could this functionality be abused? And then how can we prevent that? And then there's this idea of threat model as code. So the idea for all of these is basically, what should we spend limited AppSec engineer time on? Okay, so security engineering. The core idea here is building libraries and tools that are secure by default for developers. And I want to emphasize that framework and tech choices really matter. Right? So if you make the right choices here, this can mitigate whole classes of vulnerabilities later. So I included this picture of the Wild Wild West because that's basically where we were in web security in the early 2000s. And I believe the core reason for that is that developers had to manually parameterize queries. They had to manually output encode. Basically, they had to remember to do something in order to not screw it up. But with object relational mappers, default output encoding, all these things have sort of systematically reduced these types of issues over time. So when you're thinking about where do we focus these efforts, generally managing secrets, anything related to crypto, authentication, authorization, SQL file system access. All of these things are good areas to start, but really it's broader than this. These are just some examples. So just some case studies. I know one company who ported their front-end code to React, and that essentially killed cross-site scripting. Another wrote this data model wrapper library where all data access had to go through in order to access any customer data, and that basically killed SQL injection. And the core idea here is if something is hard to do securely, if you have to just be aware of various threats, just like build a secure by default implementation and then have everyone use those. One quote from Asta I like a lot is, hitch your security wagon to developer productivity. Right? So the secure version ideally has an even better developer user experience than the old way. Another key insight is if you integrate security at the right points, you can get adoption much easier. So say, for example, there's a new project starter template where every new, say, Golang microservice just clones that and then starts building. If you can put your security controls into that, then everyone who builds from that is going to get it for free, and you don't have to sort of convince them to adopt it. OK, let's talk about detection and response. So this idea, I think, is pretty neat. Essentially, it's when a fishy event occurs, maybe a developer is running some command on a production server, you send them a Slack message and say, hey, was this really you? And then they have to say, yes or no. And you only send it to the SOC or IR team to investigate if they said no. Right, so essentially, again, we're trying to free up security engineer time as much as possible. So what I like about this is we see Slack writing a blog post about it in 2016. Then Dropbox writing a blog post about it and releasing some POC code in 2017, and then Pinterest talking about it at a different conference in 2018. So we can see this idea sort of moving across companies, which I think is pretty neat. OK, so here's a blog post I like from Dropbox about how they handle threat detection. So basically, if something sketchy happens, there's a Kafka alert, which messages this other system called Alertbox, which then grabs information from disparate systems, basically all the context you might want to know. Then it sends to this microservice called Forerunner, which is running some sort of heavier analysis and running steps in a Jupyter notebook that say, for this type of event, this is how we respond. And then the analyst is then given this Jupyter notebook environment where all of the data has been gathered. There's all these clear steps that have already been taken. So it's easy to repeat across every analyst because the steps of what to do are documented. And also any additional investigation they do is then saved in the notebook. So you can go back later and say, oh, did we do the right thing? Should we maybe change this process in the future? Another idea is automating SOC runbooks. So basically, rather than manually responding to everything, define your response process, and then have some lambdas automatically spin up to either call the relevant security products, run custom scripts, and so forth. So Twilio released a tool called Sockless. Auth0 talked about this as well. And then the AWS Security Hub has a nice blog post about this idea also. OK, so core takeaways here. If you can push first-line triage to developers or people who are just not the security team, that's nice. Any context that the human analyst needs to proceed, just gather this automatically. And ideally, you want to document runbooks for how you respond to different events so that you have some standardization, and then automate them. OK, cool. We're doing so well. We're almost there. I paid a graphic artist a lot of money to make this because I was like, security endgame, we should have a cool thing. Boom. So yeah, so these are the aggressive long-term stuff. OK. So the first thing is one of my favorite tools and ideas by Travis of Netflix. So when you create a new service at Netflix, it's given a base set of permissions. And then essentially what RepoKit does is it watches how it behaves over time. And then if it doesn't need permissions it's given, it just takes them away and then watches if the app starts failing. So basically, without talking to the security team, every app is gradually converging to least privilege, and apps that don't need any permissions converge to 0. So this is pretty awesome. More recently, Kennard from Salesforce wrote a tool called Policy Sentry that comes at it from a different angle. Like, how do we make least privilege policies from the beginning rather than removing permissions later? So let's look into that a little bit more detail. Why is that so awesome? So the ongoing time requirements from the security team are essentially none other than maintaining the tool. But the security benefit and the risk reduction is huge, right? Like, how much work would it be to manually look at every single microservice in your company and say, oh, like what exact permissions does this need in AWS, right? That would both be point in time difficult and just impossible over time. So anytime you can find opportunities like this, you should take them. Specifically, we're trying to maximize the ratio of security ROI to the ongoing time requirements for the security team. Okay, targeting vulnerability classes. Again, this is another slide from Arcadie's talk. So this is vulnerabilities by category. So again, when you're doing vulnerability management, you could say, oh, these are the issues we have the most. Maybe we want to start there. Okay, so a number of projects at NCC started like this. Hey, we're not getting a lot of value from this popular SaaS tool. Can you look at how we're doing things and just help us get more value? So the initial ask was like, how do we get more value? What does that actually mean? Probably it means something like, how do we find more bugs of higher criticality with less manual time? But if we take a step back, I think what we care about really is just how do we find bugs more efficiently regardless of the approach? And taking another step back, given limited AppSec engineer time and budget, what's the best way for us to overall reduce risk? And again, this is not tool or approach specific. Okay, so how to do this at your company? So aggregate your vulnerabilities over the past couple of quarters or couple of years. Group them by the vulnerability class as well as how you found them. And you want to probably weight by how much you care, how severe were they. And then think what can either find or prevent them at scale. So the goal here is minimizing cost, either bug bounty pen testing directly or tool licensing, as well as AppSec time in terms of finding manually, triaging results, and so forth. So is one method finding all of your issues? Have you had other success stories in your company that you can leverage and learn from? These are useful things to think about. So let's say, again, another example. If you can see where are all the vulnerabilities come from, you might be able to say, oh, we see this tool or this, say, pen testing or bug bounty is finding most of the issues that are high impact that we actually fix. Or this approach is finding things that usually we just mark as don't care. So maybe we want to deprioritize that. So let's look at a specific example. Let's say you did a time audit of your AppSec team, and you're like, this is sort of how we spend our time. We spend a fair amount of time dealing with XXE, a little bit manually running security tools, and so forth. So let's say, hey, we were spending a lot of time on XXE. Let's drill into that more. Like, what are the subcomponents of that? So you might say, okay, well, we're doing some developer training. We're triaging bug bounty submissions. We're working with developers to fix the issues as well as validating that the fixes actually worked. We're configuring both SAST and DAST tools to do that. And the point here is all of these are continuous, ongoing, recurring operational time costs, right? These are things that you're doing that are preventing you from doing other things. So what if we were to instead, say, build a safe by default wrapper library for parsing XML that disables DTDs, and basically if you use this version, you're safe. And then you teach developers about this library and then roll it out everywhere. And then you have lightweight scanning for every pull request, which basically says, hey, if you're doing XML parsing, are you using the library we wrote for you? And then if not, maybe warn or block. And then basically you're done, right, by construction. You don't actually have to do all of this complicated bug finding analysis because you've just eliminated it by construction. So Morgan Roman from DocuSign gave a nice talk about this approach where he describes how they eliminated regex DOS, XXE, Open Redirect, as well as SSRF, basically by secure by default libraries, as well as ensuring their use. Right? It's a simple idea, but I think very powerful. So let's go back to your AppSec time. So where we were previously spending time on XXE, we've essentially eliminated that. So now that time we were spending there, we can now start devoting to other areas. So we might say, oh, we're manually running security tools, maybe let's automate that a little bit. And then boom, now 50% of your time that you used to be spending on other things is now free to invest again in further high leverage activities. So the point here is we're basically trying to build a AppSec snowball where we are systematically becoming more effective and our efforts more scalable over time, right? Rather than playing whack-a-mole a bunch of places, we're trying to have compounding returns on our efforts. So again, what I like to say is security engineering is the compound interest of security. right? So you might be putting in some time here this week and maybe in the next few months, and you don't necessarily see a lot of value immediately, but over time, you are investing in things that you can build upon, and you're just becoming more effective, higher leveraged over time. Also, when I wrote this slide, I wanted to point out that quoting yourself is kind of awkward. Obviously, Gandhi said that. Okay, so targeting vuln classes, use your vulnerability history to determine where to invest effort. Consider the vulnerability classes, like what's finding them, what's their impact, what's the most effective way in terms of time and money to reduce risk, and solving bug classes amplifies your effectiveness. Okay, last topic, enforcing invariance. So I think this idea is super neat. And the idea is essentially you want to enforce or alert on things that either should always or never be true in your environment. For example, you might say AWS instances should never be accessible on all ports to the whole internet. We should just never do that. So Datadog had a nice blog post where they essentially described a system where a Lambda will spin up and auto shut down any EC2 instance with this policy. You might say, oh, we have all of our developers using Terraform, so manual changes should never be made through the AWS console. This should just never happen. So Arcady has a nice blog post about how to do this with CloudTrail. Another idea is we should never use these regions or these cloud services. Like in our company, we always use, say, US East and these 3 AWS services, and we never use anything else. So if something spins up in another region or another service, this is probably a red flag. Either a developer is doing something new that they maybe shouldn't be doing, or it's an attack. You can also go further and do this perhaps per app or per service. And this was described as well as a bunch of other excellent ideas, not this most recent, but the AppSec Cali before that by Will and Travis of Netflix. Okay, so the idea here is what are things in your environment that should either always or never be true, either with your cloud environment or your security controls or code and so forth. And then which of these can you programmatically enforce or alert on? And the key intuition behind this is that if you don't need any context to make the decision, right? There's no sort of like, oh, well, sometimes this is okay, but there's all these other mitigating factors, which like a human needs to make. So if there isn't that, then you can just programmatically enforce it, and then there's no operational time for the security team, so you just sort of, whack that mole once, you just don't have to deal with that anymore, and then you spend your time on other things. So again, we are trying to knock off things from our plate to become strategically more effective over time. So I would encourage you to think, how is what we're doing now making us more effective in the future, right? So if it's not, I would consider deprioritizing it. And then obviously Gandhi also said this. Okay, so we covered a lot. So let's put it all together. So I'm going to talk about some things you can start doing immediately, like say this or next week, some things you can do in the medium term, and some things you can do in the long term. Okay, first, step 1 is assess. Figure out where you are now. So evaluate the fundamentals. Are you tracking all of your vulnerabilities in one system? Are you tracking the right metadata, et cetera? For continuous scanning, what sort of capabilities do you have? Can you roll out a new tool or remove a tool very quickly and easily? Then asset inventory. What visibility do you have into your environment? And I would encourage you to set up a meeting with security leadership as well as developer subject matter experts and figure out, based on where we are, is there vulnerability or asset inventory information that we would like? Is there promising projects we should do? And then in the 3 to 9 months, start building based on what you've assessed. So nail the fundamentals. So here's where we are, here's where we should be to have all of these covered, to build a strong base from which we can build in the future. And then take on one bite-sized project based on your historical vulnerability data and your company's business factors and risk. So the key thing here is bite-sized project, right? You don't want to necessarily say, oh, let's do this crazy, complex, massive project that's only going to be valuable like 2 years from now. ideally, it's something you can do in a few weeks or in a few months so that you can prove to yourself, as well as management and executive leadership, it pays to invest in things. We spent time building this thing, and look at all the security benefit we're getting in the future. We used to spend a lot of time, triaging and fixing all of these issues. Now we can spend that time on all these other things. And then in the future, so you've assessed, you've built, and now you start scaling. So you want to be more highly leveraged with your time. Ideally, you can target specific vulnerability classes and just eliminate them categorically. You can invest in projects with high security ROI and minimal ongoing time requirements. For example, automating least privilege or invariance. And again, you want to focus on areas that meaningfully raise your security bar. Right? So there's things that might be technically very interesting. There's things that might be fun to work on that seem like they're going to be good, but are they actually going to move your security needle? Are they going to raise your security posture? OK, so let's just quickly wrap up. For some reason, I decided it would be a good idea to watch every AppSec Cali 2019 talk and write a detailed summary of them. The answer to the question you're thinking is it took hundreds of hours. But if you would like to benefit from that, you can read it right there for free. Also, I have a newsletter where I summarize talks, link to tools and resources I find useful, as well as write about things I work on. So at least one person doesn't hate it, so you might like it too. OK, so thank you so much for your time. These slides are live already. You can go right there. I'm happy to chat on Twitter as well as LinkedIn. Again, there's a link to the newsletter. If you think that robot is cute, I have an egregious number of stickers in my pocket and in my backpack that I'd be happy to give you. And there's some key insights from sort of the whole talk in case that helps you with your question asking. And actually, since I have time, I just wanted to say a big thank you to all the people who did the work that was referenced in this talk. You're really pushing the industry forward, and I and others have learned a lot, and I appreciate it. And there's a number of people who reviewed early versions of this talk and gave me excellent feedback. So if you like this talk, big thanks to all these people for making it happen. Yeah, I believe I have a few minutes left for questions. And also, when time runs out, I would be happy to chat here in the hall, et cetera. So thanks again so much for your time.
All right, everyone. Please join me in giving Clint a big thanks for joining us. If anyone has any questions, just raise your hand real high, and I can bring you the microphone. See one over here.
Hey, great talk, Clint. You talked about threat modeling as code. Can you explain a little bit more what that is and how it's different from just traditional threat modeling?
Yeah, that's a good question. So the question is, can you provide a little bit more detail about threat model as code? So there are a number of backup slides that you can see on this. But the idea is, can you express security properties you want or abuse cases of the system in sort of a security integration type test such that they are continuously run as the application is built? That's basically the core idea. There's more details, but yeah.
Other questions? Raise your hand real high. We have oh, yes. Right in the front.
So if someone is going to start an application security right from the beginning, like it's just a free-for-all, what would be a good way for them to start if you could give them one or two things to do? What would be a favorite advice that you would give to a company?
OK, thank you. If it's a free-for-all, where should you start? I think one thing that I didn't talk about as much in this talk because it didn't quite fit in as theme. But I think building really good relationships with developers is absolutely essential. If you can have just the culture of the company be aware of security and even have the intuition of like, oh, this is a thing that might have security implication, let me go proactively talk with the security team, then that can go a long way before you necessarily have built the infrastructure to have like continuous, say, asset inventory type visibility into who's pushing code and what it's doing. So I would say definitely that. I think you can get a lot of nice wins by tracking vulnerabilities in terms of like what type of vulnerability was this, how much did we care about it, and things like that. There's various metrics and high leverage things you can do, but only once you have the data. So the earlier you can start collecting it, the sooner you can start doing that. But yeah, thanks so much for the question.
I think we have time for one or two more. I'll see one right here.
I don't necessarily disagree in regards to suggestion that if you found these kind of vulnerabilities, let's keep looking for these kind of vulnerabilities when you're trying to optimize your time. But isn't there a risk that you're looking for the things, the low-hanging fruit maybe is starting to be whittled down, and you won't find it there, and you maybe have blind spots other places? How do you balance sort of looking for the things you haven't discovered versus spending more time kind of with that low-hanging fruit?
Yeah, that's a really good question, and I don't think there's necessarily a simple answer. But yeah, so the question is, here's the issues you've had in the past. If you just focus on those, maybe there's important things you're blind to. Yeah, I think it definitely is easy to get caught up in like, oh, here's the historical vulnerability data, let's focus on those, and not necessarily have this be sort of continuously changing over time. Ideally, as you're getting better, there are things that were comparatively less of a problem that you can now focus on. And I think one interesting unintuitive point that some people don't think about is, like, as you get better at a lot of these things, you're going to start finding more issues that have always been there, you just didn't know they were there. So in the short term, as you're improving from a metrics point of view in terms of number of vulnerabilities found, it can actually look worse, right? So I think one security metric that initially you might think is great, like number of vulnerabilities found, can be deceiving in that as you get better at finding them, you're going to find more. But yeah, so I agree with your point in that you don't want to be overly focused on just like these issues are things we've had in the past. I think one way to get around that is sort of holistically, maybe biannually or quarterly, like taking a step back and thinking, are there important business risks that we are ignoring based on our current process? There's like MITRE and NIST have, NIST, for example, the cybersecurity framework has like different areas and levels of investment and things that you can sort of have a standard to compare yourself against, similarly with OpenSAM. But yeah, I think the key is to sort of continuously reevaluate where you are and what makes sense. But yeah, that's a really great question. Thank you.
All right. I think we are just about out of time unless anyone has one last quick question. No? Okay, well then please join me in thanking Clint. Clint, thank you so much for being a speaker at BSide.
Thank you.